This tutorial is very similar to the last one, except that each of the pieces is exactly the same. So I'd like to show you how I deal with that. The first thing we're going to need is a hexagon, and as usual I look for an SVG version, and I found one on the internet, and there it is. And as usual I put it into the center. Now it's time to make the clones. I've already worked out I need 16, and as usual we can't see them, but they're there. And what we want to know is where they should be. Get it exactly where I want it. Go behind the scenes and see where it is, and write that number down. And what you need to do now is go and do that for all of the possible positions. And when you've finished, it will look like this. This is the original sprite, still in the middle. Now what do we do with that list that you have made of the X values and the Y values? Well, we do the usual thing. We go and create a list for all sprites, call it X, and we go over here and you enter all your values in. Press enter after each one, and you'll do the same for Y. So when you've finished, it should look something like this. Next we want to give each clone a number. Do that in the usual way. The next thing I want to do is put each of these pieces in the right position. We know the right position because of these lists that we made. The way I do that is when I start as a clone, set X, set Y to item number N. We don't need N to be showing anymore, of Y, and similarly set X to item number N of X. Alright, let's see how that goes. And there you go. These are the pieces in their right position. Of course, the player will be presented with the pieces all over the place. To do that, I simply make a duplicate of this lot and go along and go to the costumes and change the color to a light grey. There we go. And there they are. But of course we don't want them in their final position, so we don't need this bit. But we still need the numbers. Now you'll see that they just all end up in the center. There they are, all 16 of them. What I like to do is to put them in a little stack down in the bottom left hand corner, and we can see here where it starts off at minus 235, minus 175. So if we start off by going there, then they all end up down the bottom corner. But what I wanted to do was stack them out so they come out in a little stack. To do that is very simple. Each time we draw one, we simply change X by, I found 5 worked rather well, and similarly Y. And you see they stack out nicely. Of course we don't want all these pieces showing, so go back here and we say, hey, when I start as a clone I want to hide. There we go, and that's the main piece still there. Now the way it's going to work is when the player takes a piece and puts it in the right position, and realize the right position could be any one of the 16 places, then we want to check whether this piece that he's just placed is in any of the 16 possible places. So we'll need to set up an event when I receive check. What I want to do is compare the position of this piece. In other words, its X position and its Y position. I want to compare that with all of the possible positions. So to do that, I'm going to need to set up another loop to go through the 16 positions. And I'll need to look at each of the items. But we'll need to have a variable here to go through. So we set up a new variable, as usual. For this sprite only, I'm going to use I, and we'll need to set I to 0 before we go into the loop. And then we'll be able to look at item I of X and item I of Y and compare those. But of course we'll need to make sure I has gone to 1 and increases by 1 each time, so we'll put that there. We're getting close. To compare these, we do the usual thing of doing a subtraction. And that goes in there like so. Alright, let's see what we've done. When we receive check, and remember, every one of these clones will receive this check message, and every one of these clones will have its own I value. You can see here how the I has just been assigned to hexagon 2, not globally. We don't need to show that anymore, so I'll take that away. And then we go through the 16 values of I, which will take us through the 16 values of X and Y, and we compare each one. Now when we find a match, then what we want to do? Well, we simply want to hide the piece. Let's see if it works. So we'll need to broadcast a check. I'll just put it here so we can try it. Broadcast check and wait, and you can see it works. Broadcast check and wait, see it works. But of course the other thing we want to happen is when a piece is put in the right place, when it disappears, we want the piece, the green piece, to appear. So what will need to happen here is we'll have to do a broadcast, and we'll call it just show. And over here in the green section, we say when I receive show, then I want to show myself. But a reminder that every one of these green hexagons will get this message, so everyone will show itself, and that's hardly what we want to happen. We only want the one that is in the position that this is in. How do we know what position that's in? Well, because it'll be this number I. But unfortunately you can't access that number I outside of this area, so we'll have to put it into a variable, and this variable will have to be for all sprites. I'm just going to call it which, and what I'm going to do is I'm going to set which to the I that I've just found. Don't need which showing anymore. Now we can go over here and we can say, okay, when I receive show, if my number, and remember my number is n, is equal to which, then I can show. So we simply get an if statement and a comparison of my n number to which. And if that is so, then I want to show. So let's start everything up and come over here. But we can't see the pieces. That's because of this hide here. We'll need to make sure they show. So we'll need to put a show in here. Now, there they are. But we'll also be including the piece itself, the sprite itself. You can see this because when you click the stop sign, all of the clones disappear. So this is the actual sprite here. So what I like to do is to hide it, but also its number will be 16 because that's the last number we put in here. So to avoid any confusion with clone number 16, I want to set n back to 0 for this piece. Now let's try, press the stop sign, and you can see it's no longer there. Alright, let's put a piece in place, broadcast check and wait, and there you go, it's working beautifully. And so on. But of course we can't sit behind the scenes clicking this broadcast check all the time. We have to set up a program to do that. So we go in here, and when the game starts up backstage, we'll first of all set up a variable to keep count. Of how many pieces have been found, and then we can put in a repeat until. Count is equal to 16. And what do we want to do in this loop? We want to keep sending out this broadcast of check. Alright, and we of course will have to, over here, every time we find a piece, we'll have to add one to count. So, ready to have a go. So put a piece in place. And you see what's happened. Count has already gone straight up to 16. And so the program has stopped. Why did that happen? Well, the reason that happened is that over here, backstage, we are sending out this check message over and over again. Here, this check message is being received over and over again, and this match is going to agree all the time, even though we've hidden. So count will just keep getting one added on. So what we need is some way of knowing when a piece has been found and not checking it anymore. What I'm going to do is I'm going to make a new list. It's going to be a global list. I'm going to call it done. And I'm going to fill it with a 0 for each of the 16 pieces. We do that backstage by setting up a loop of 16. And we want to add 0 to done. And we also remember when you do this, if we do this over and over again, we'll get 16 values added each time. So the trick is that one always has to remember to delete all of the values before doing it. Okay, let's see how that goes. Okay, we don't need to keep looking at done. Put a piece in place, and again, done has gone up to 16, but that's because I forgot to make use of this done here. So what we have to do is when we find a piece that matches, we have to replace item number I of done with, let's say, 1. Okay, let's see how that goes. We'll leave done on the screen so you can see it, and we'll start again. Put a piece in place, and you see number 10, we've got a 1 there. But of course we've still got this going up to 16 because we haven't made use of the fact that item I of done is now 1. So we need another loop and another test, and we ask ourselves whether item I of done equals 0, and if it is, then it's worth doing this test. But of course if it's 1, then we don't bother doing this test. Alright, we can take done away now, start again, put a piece in place, and you can see count stays at 1. So we take count away, the whole game should now work perfectly. And when we go back behind the scenes, you notice that the green flag is off, the game has stopped. Okay, so that's all I wanted to show you on this one. This is how I deal with all the pieces being the same. And just before finishing, I'd like to show you another design that I used, another tessellation as they're called. And this one is far more interesting, both for you as the programmer and also for the puzzler.